Hello everyone, myself Brunda. I am currently studying at Sri Venkateshwara College of Engineering in 8th SEM. Today I am presenting my technical seminar on an intelligent IoT and ML based water leakage detection system. The contents are introduction, related background, working or implementation, applications and future enhancement, conclusion and finally references. Let me move into the introduction. Water is a limited resource, with only 2.5% being fresh water and just a tiny portion, 0.0072% available in surface sources like rivers and lakes. Most fresh water is trapped in ice or underground, making conservation and efficient management crucial. To reduce water loss in pipelines, IoT and ML are used with wireless sensors network to detect leaks. The system includes sensors, GSM modules, Raspberry Pi, and alarms that send SMS and telegram alerts. It also controls pump operation based on tank water levels. This smart system improves efficiency, reduces maintenance time and cost, and supports sustainable water use. Smart leakage detection. What is meant by smart leakage detection is an Internet of Things and machine learning based system using wireless sensors detect leaks, monitors tank levels and controls pump. It sends alerts via SMS and telegram, reducing water loss and cost and maintenance time. Overall, we use the Raspberry Pi GSM module, sensors and alarms to get the notification. Let me move into the related background. What the mean by related background? In the year 2025, the author Paur Merani, the title is Water Flow Detection Device based on sound data analysis and machine learning to detect water. He uses the key technology mechanical sound amplification in pipes plus ML classification, where the limitation is limited by pipe diameter, where VACVET at the year 2024 investigating the sustainability of concept drift detection for detecting leakage in water distribution. The limitation was needs frequent model update because it was on the basis of drift. Bosch at the year 2023 leveraging IoT for detecting power and water theft in urban environments. Edge deployed anomaly detection on consumption patterns via isolation forest, where the limitation was regular sensor recalibration both for Fernandez in the year 2023. They have been limitation for regular sensor recalibration. Okay, last W leveraging optical communication fiber and AI for distributed water pipe leak, where he faced a limitation for very high implementation cost. The cost was high. As for the authors and my work differ with only the they are used separate Internet of Things and some of them use the ML based and some of them are used with drift. But in my work I using IoT and both ML based I am using in this. Next we have been working for implementation. In working implementation, the first step is data first step is data acquisition. What can happen in data acquisition? Here data can be captured through the experiment. In the first step where data can be captured with the help of the experiment. Next, in the second step where the data set generation will be take place. We have two type of the data set will be generated, leak and non-leak, with the help of the ML algorithms. In the third step, audio clipping. What is audio clipping? In the audio was clipped for 0.5 seconds. If the clipping was been set for 0.5.5.5 in the smaller range, it was helpful in identifying the robustness and all, and with the 25% of overlapping. Next, in the fourth step, we are using data augmentation. Here we uses adding the noise and echoes to check for robustness, where the natural environmental factors we have been going to add it. Next, fifth step, pre-processing. In the fifth step, pre-processing we use it for two types: feature extraction and data balancing. Feature extraction can be done by using the my machine learning algorithm, and data balancing can be done with for both leak and non-leak. Next, we are using the ML model ANN and CNN. We use the two ML models for for about two algorithms, ANN and CNN. Next, we use for model shrinking. In model shrinking, quantization and pruning, where it removes the unwanted things in the model. Final model selection. Finally, the model was selected based on F1 score. It is the working flow of the which consists 4 parts. Only first one is experiment, second one is dataset generation, third one is ML model training, fourth one is hardware development, and finally the result. First we go with the experiment. It is an water flow setup. Water flow setup first consists with water supply. Water supply enters into the initial valve. From the initial valve it enters into the valve. In the valve the pressure down, the water will escape, and the pressure can be measured with the help of the pressure meter. In the variation tab we have the 3 factors. One with leak size, we can identify the leak size, water pressure and sensor location. These 3 play a very vital role in the experiment part, and it consists the sensor, preamp design and data capture. Sensor is mainly provided for water initial valve, and the preamp design will helpful for modifying of the weak signals for the higher capturing of the data. Then data will be sent for the signal due to water flow. In signal due to water flow, which consists with non-leak noise and leak noise, we have non-leak noise like EPN, WFF, WENF, and the leak noise is WLN. From the leak noise and non-leak noise, we enter into data formatting. Data will be formed like after data formatting we need to have the data labeling. After data labeling, the data set will be formed. We have noted data set is like leak and non-leak. We have been previously discussed about it. Let me move into the data set. Will move into the audio clipping. Audio clipping I have been explained with 0.5 second, and where the clipping with overlapped with the 25%. Next is move into the data argumentation. In data argumentation, I have been said previously, in the data argumentation we adding the noise. We add noise and echoes for checking the robustness, and feature extraction data balancing. In this step I said feature extraction data balancing or the pre-processing technique. In data balancing we have seen leak and non-leak type. For checking the leak and non-leak we have in training and the testing part. For testing we have been 30% of testing part, and training we will give for 70%. Finally, we will go into the ML model. You have been know that ML model is the 2-type leak and non-leak classification can be done, and it is also moved into the quantization and training. This is the step where I have been said model shrinking of the model with the help of the quantization and training. After final model selection based on the accuracy, recall, precision and F1 score. Okay, in the hardware development, what you have been saying sensor, which comes with the hardware and firmware type. In the hardware type, we have the schematic design. We have obviously schematic design, PCB design, assembly, power generation, power consumption and testing part. In firmware we consider real-time operating system, which consists task 1 to task n can be performed, and it can be used for testing purpose. Final result can be selected based on F1 score. Let me move into the applications and future enhancement. We have been seeing 4 type of the applications: smart cities, agriculture, industrial use and residential areas. Mainly we see the application in smart cities. Smart cities real-time water monitoring and leak detection in urban infrastructure. Mainly smart cities we have been seen in the leak detection in the urban, we have to be reduce the leak water leakage. So using in the smart cities it can be very helpful for the urban areas. Second application we have been seen in agriculture. What is in agriculture? Efficient irrigation by detecting underground pipe leaks and managing water levels. We have been look over with the agriculture. Efficient irrigation. For the irrigation purpose, if the water was leaked, there is a wastage of the water. So we have been using IOT and ML based water leakage detection and underground pipe. It was helpful for managing water levels, so the water will not be moved out. Next we have been seen industrial use. Industrial use, monitoring and maintaining pipeline in factories to prevent water wastage. Mainly in industries we use the water level for need to maintain the proper water level, like not in the imbalance waterway and not in reducing the water wastage, save the water. Next, fourth one advantage is application is residential areas. In our household activities also can be implemented. Automated water level tank control and leakage alerts for household. If there is any leakage in the pipe and all, we can be get the monitored by the GSM module. These are the 4 applications we have been seen. Next I look over with the future enhancement. What is the future enhancement by using a IoT and ML based water leakage detection can be seen here. Firstly, we are go with AI integration. AI integration advanced prediction of leak before they occur using AI algorithm. We can get to know before only. Cloud connectivity, storing and analyzing long-term data for better water usage insights. Solar power sensor, energy efficient system for remote or off-grid areas. Fourth one, mobile app interface, user-friendly apps for real-time monitoring and control. Scalability, expanding to cover entire municipal water system with minimal manual intervention. Let me move into the conclusion part. The combination of machine learning algorithm and IoT for water leakage detection represent a significant advancement in modern infrastructure management. We have been look over it both of them in the previous slides only. Utilizing sensor network and data analytics, this approach delivers accurate leak identification while supporting proactive maintenance and efficient resource use. It also improves the speed and effectiveness of decision making, boosts the reliability of infrastructure, and reduces operational interruptions. To fully realize its long term benefits and promote broad adoption, continued research, collaboration, and attention to scalability remain crucial. We have been look over that it was helpful in the advanced. We get to know that leakage and detection can be stopped, and water wastage can be reduced, and it will save the water. And we have to get to know the earlier only. These are the references what I've been referred. Thank you.